Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share the video across with a friend. Make sure you subscribe. If you have subscribed before, share to your friend and leave a comment behind. On this video, I'll be working on summation notation problems. There are videos already on summation notation, just for better understanding, so that it will be very clear to you. Now, our aim in this platform is any student that comes in should be able to go out without any stress. Now, I just have this question to work on, and permit me just to solve, and let's see how it will go. Now, the first one says that find the number of k such that summation, which is sum of I to 1 run to k, I equals to 170, which is these are the options. And let's try to work along with this question and see how it will go. Now, the first thing you need to ask yourself is that you know that this of I to k, not j, this is I, sorry, now equals to 78. Now, what you just need to do now is that now this is equals to this, and don't forget that recall from mathematical induction. Now, which I've showed it in the last video, how it goes. Normally, we have a summation of, for something like this, I to what? To n. Okay, let me use k this time around because the story has changed. K of I will be equals to n bracket of n plus 1 divides by 2. That is what that is all about. Since is that, it means of this particular one, which is of one to k, will be equals to of I 78 will be equals to k bracket of k plus 1 all over 2 equals to 78. Now, at this junction, I'll be having k squared plus k equals to 78 times 2, that will be 156. That is what we're going to be, and just multiply by 2, which is this, we cancel this. Now, at this junction, I'll be having k squared plus k equal minus 76, 76 equals to 0. Now, this is a common quadratic equation that every one of you is used to. Now, at this junction, I want to solve this particular problem. Now, how do I solve this problem? What I will just do, a number that will multiply, that will give me two numbers that will multiply, that will give me AC, and the same number will be added. It will give me B. That is the number that will represent. I can see 12 multiplied by 13. Now, for me to have this, it means I will be having it means I'll be having this. Now, I think that it will give me what I need. With that, I'll be able to get what I need. Now, since I have that, I think I'll be having k squared plus 13k minus 12k minus 156 equals to 0. Now, at this junction, I'll be having k bracket of k plus 13 and minus 12 bracket of k plus 13, which is equals to 0. Now, my k will be equals to, I'm not teaching elementary mathematics, but let's see, I'm so sorry because this is not an elementary mathematics. Now, by so doing that, I'll be having my k minus 12 equals to 0, or k plus 13 equals to 0. Now, my k will be equals to 12, or my k will be equals to what? Minus 13. Now, note that this can never be an answer. Please, not, but this is the answer. It means my k equals to what? 12. Now, interpretation means what? It means from there, I can say that my what? Summa of what? of I to 1 equals to what? K, which is what? Ij will be equals to summation of what? 1 to what? K equals to 12. 12 of I, which is, if you sum it up, it will give us 78. You can try that on your own for you to understand what I'm trying to explain there. Now, that is settled. Let's talk about the second question, which is also a very simple one. Now, I was given something like this to solve. How do I solve something like this? Solution to this problem. Now, it's a very simple one. This time around, you are having a function, which is, I can see, whenever you hear word function in mathematics, please relate towards mapping, input and output. Please, it's very important. That is elementary word, input and output, which is, you will be talking about domain and codomain, or image and pre-image. Now, this is a very good example of it, but this is a function on a what? On a sequence, on a summer notation. Now, this comes like this, n to 1 and run to 3, n x. Now, this could be a very simple question. What you just need to do is that this will be equals to, now I'm trying to walk along with this, it runs from 1 to 3. Now, it means at this junction, I'm saying that 1, x bracket of 1 minus 1 plus 2, x bracket of 1, 2 minus 1 plus 3x 3 minus 1. Now, at this junction, I'll be having, I'm not talking about, you have to understand. You have to understand at this junction, it means I'm talking about x raised to power 0 plus 2x plus 3x squared. Now, for me to have this, it means that's the function. This is the function. This is the function I'm talking about. Now, this function is equals to this. I've tried to deduce or take away the notation, the summer notation attached to the function. Now, at this junction, I can answer that what? At x equals to 3, because that is the maximum. Now, at x equals to 3, what I will just do is that it means my function of 3 equals to what? This will be 1. Sorry, permit me to write this. This is going to be 1. We all know that any number raised to power 0 is 1. Now, it means I'll be having 1 plus 2 bracket of 3 plus 3 bracket of 3 squared. Now, at this junction, I'll be having 1 plus 6 plus 27. Now, which is 27, that will be 24, 23 and 24. 34. Now, 34. It means my function of what? Of 3 equals to 34. 34 should be there. That is option A. Now, can you see that is all about that? I think at this junction, you'll be able to solve any question on summer notation. Note that this time around, we apply this to ODE, ordinary differential equation, power series. Let me use the word power series. I think there are some of videos on it on our channel. You can come and learn on that. No problem. You'll be fine. Once again, thanks for watching.